Hello, Professor Venus here. Today we're going to work on Chapter 2, Nomenclature, Naming Compounds. This is almost at the, let's say, the second half of your Chapter 2. So let's see what we can get done in this topic. There are different types of chemical compounds. The first type is ionic compounds, which is a combination of metal and nonmetals. As you know, metals are on the left side of the periodic table, nonmetals on the right side. Metals tend to lose electron, form a positively charged ion, which is called cation, like sodium in group 1. And nonmetals on the right side of the periodic table tend to gain electron and form a negatively charged ion, which is called anion, like chlorine in group 17. So, cations with the positive charge will stick to anions with the negative charge, and they will form ionic compound, like NaCl or sodium chloride, which is table salt. All right, ready to start these types of compounds? Cations. First component in ionic compounds is a cation. So, cations can be monoatomic, can be formed from one type of atom, or can be polyatomic, can be formed from more than one type of atom. So I started with polyatomic cations because we only have one polyatomic cation which has been synthesized in the lab. It's not a natural cation. It's natural and not naturally found in the nature. So the formula, I want you to memorize the formula. The formula is NH4, and this positive charge belongs to the entire compound. So this is called ammonium ion. As you can expect, it comes from ammonia gas. So NH4 with a positive charge is called ammonium ion. We memorize it. Okay? So now let me go back to monoatomic cations, which needs more work, and I can tell you, like, the headache of naming ionic compounds, or let's say just naming compounds in general, is the monoatomic cations that you have to be careful how to classify. But not a problem, you have this video available. Any other videos you would like, you can pause them as many times as you want and figure out what's happened during their naming. So, monoatomic cations can be, first, they're metals. We said cations are formed from metals, right? So, metals can be in groups 1 to 13. I want you to have a periodic table in front of you and check with groups 1 to 13. Do you all see them? The tall groups. So, if metal that forms cation belongs to these groups 1 to 13, the charge on the cation is going to be a fixed charge, and it's going to be the same as group number. Like, if the metal is in group 1, the charge on cation is going to be positive 1, in group 2, positive 2, and in group 13, we will work with this last digit. So the charge on the cation is going to be positive 3. How to name them? Because there's no complication in charges, the charge is fixed, you just bring the name of the parent atom plus the word ion. So, please help me. Look at sodium in your periodic tables, it's in group 1, right? So the charge is positive 1. In general, we don't write 1 in the chemical formulas, right? So, can you help me write the name for this compound, for this ion? This is simply called sodium. That's the name of the parent atom, right? This is called sodium ion. When it's by itself and you see the positive charge, it's called sodium ion. Let's go to group 2. Calcium. Calcium is in group 2, so you see it will create a positive 2 charge always. So we just simply call it calcium ion, right? And finally, aluminum is in group 13. I told you they get the charge of positive 3. So we just call it aluminum try to name the other ions and also write their formulas of groups 1 and 2 especially, and aluminum is the most famous one in group 13. So don't worry about the rest of them in group 13. We will talk about them, but aluminum so far is the only element with a positive 3 charge which forms a cation. So I would expect you to try to write down the charge on the cations of groups 1 and 2 and try to name them. Alright? Okay, let's move towards the second category of metals in transition elements, in transition metals, which are in groups 3 to 12. In this case, we have to be careful. The charge on the cation is different. So the cation has various charges, and you need to mention that, okay? Don't forget to mention it. How to mention it in Roman numerals, not in English numbers, make sure, and inside parentheses. This type of naming is called IUPAC name, because in the next slide I'm going to introduce another type of naming. So if this is our various charge cation, you see iron can get a positive 2 charge, can get a positive 3 charge. Copper can get a positive 1 or can get a positive 2. So let's try to name the first one together. The name of element is iron. 2 in Roman numerals inside parentheses, and it's an ion, right? So it's iron 2 ion. For the next one, you just need to change the charge, correct? All right. For copper, don't forget that in English we spell copper different. C-O-P-P-E-R. What's the charge? Positive 1. And don't forget to close parentheses. All right? Now, copper with a positive 2 charge is called copper 2 ion. Huh? It shouldn't be that difficult if you have enough practice on them, right? You can do it with some other transition elements, not all of them. You will see the exceptions. I told you the other type of naming was called IUPAC, International Union of Pure and Applied Chemistry Method, which is easier and it's newer. But before that, IUPAC naming or systematic naming, there was an older method to name these various charged cations. How did they do it? They took the root of original name, okay, Latin name, and added OUS or IC to it. How? Fe is the symbol for iron, but its original name is not iron. It has been ferrum. That's where Fe comes from. Okay? So, take the root for iron 2. For the cation with less charge, we put OUS, so it's called ferrous ion. So iron 2 was used to be called ferrous ion. I expect you to know that, okay? Because there is still some occasions that these older names are used, and I want you to know them. Again, for the next one, for iron 3, you use the root. This time IC. So instead of using numbers, they used to realize the charge, the difference between the charges, not the charge itself, from the difference between the suffixes that came after the root. For copper, why the symbol is Cu? Because it was cuprum. Okay? Now, you say cuprous ion, and for the second one you call it cupric ion. Make sense? You don't have that many of them, but let's just learn it from iron and copper. Okay? Now, we are done with naming cations. Let's focus on the anions. Anions, again, they are formed from either one atom or more than one atom. And don't forget that anions are formed from which type of elements? Nonmetals, right? Okay, so for monoatomic anions, when your anion is just composed of one element, you should pay attention to the group of the nonmetal. The nonmetals are in groups 15, 16, and 17. Check with your periodic table you have in your hand. You see them? 15, 16, 17. The charge on the anion is always their group number minus 18. So, tell me, if nitrogen is in which group? 15, right? 15 minus 18 is what? Negative 3. For oxygen, it's in group 16. 16 minus 18, negative 2. Fluorine is in which group? 17. So what's the charge? Negative 1. As far as their naming, the naming is simple on the anions, on monoatomic anions. For their naming, use the root of element name plus the suffix IDE. So, for this ion, you simply call it nitride. Don't forget that they need to be easy to pronounce also. So instead of nitrogenide, we just call it nitride. Instead of oxygenide, we call it what? Oxide. And fluorine, fluoride ion. So that's how you name the monoatomic anions. You see, it's much easier than monoatomic cations are. Okay, then I hope you have learned how to name monoatomic anions and cations so far. Let's move towards polyatomic anions. And what you see here, you need to memorize. So use flashcards, start writing them all over and over, whichever method you have for learning. I want you to focus on the first set of the polyatomic anions. Look, NO2 with a negative charge, NO3 with a negative charge. So what is the only difference between these two? Nitrogens are the same, the negative charge is the same, the only difference is the number of oxygens. How to name these polyatomic anions is that we need to bring the root of the first element, nit. The first polyatomic anion, which has one less oxygen than the other one, will end in ITE. So this is called nitrite ion. The second one, again, use the same principle, but it will end in ATE. So we just distinguish between the nitrite and nitrate, which the difference is one oxygen with these suffixes, ITE and ATE. No one tells you how many oxygens in them. That's why you need to memorize them. The only thing that shows the difference is ITE or ATE. So can you apply the same rule on SO3 and SO4? Sulfite ion, again, ITE, and sulfate ion. Okay? How about PO3 and PO4? Again, it has to be easy to pronounce also. Phosphite and phosphate, right? Okay? Are we good so far? All right, we still have some more polyatomic anions. We're not done yet. It's a pretty big list. So for elements in group 17, especially for chlorine and bromine, you will see instead of 2 types of anions, you will see 4. So I want you to focus only on these 2 first. Which one has less oxygen? ClO2, right? So how do you name it? Chlorite. Chlorite ion. The second one is called chlorate ion, correct? So, in order to name ClO and ClO4, we have no other choice but use prefix because we already have used the suffixes, right? So, for ClO, which has 1 less oxygen than ClO2, use the prefix hypo. Have you heard hypo before, especially in biology? Shows deficiency or lack. And here we use it for the minimum number of oxygens. So it's simply called hypochlorite ion, right? For the ion with maximum number of oxygens, use pair and then continue with chlorate. Because perchlorate shows that anion has 1 more oxygen than chlorate. All right? I told you, you have a lot of memorization. I'm not going to provide this list for the first exam, so buckle up. And finally, the last set of polyatomic anions that I want you to memorize are these that they don't have a pair, but we just name them. Let me change the color. This one is called carbonate. Just memorize them. These 2 are a little bit weird. They are polyatomic definitely because they are composed of more than 1 atom. But we kind of we do not follow this procedure, this rule. So this is simply called cyanide ion. And this one is called hydroxide. You can bring the word ion after all of them. This is called chromate, CaRO4 with a -2 charge, chromate ion. And Cr2O7 is called dichromate because we have 2 chromium ion in the chromium atom. MnO4 is called permanganate. Permanganate ion. And the last one is an organic ion. Those of you who go to organic chemistry course, you will learn it. It's called acetate ion. That's the ion in vinegar. All right, so let's not forget about the exceptions. I'm sorry, there are some exceptions that you need to memorize in monoatomic cations. Again, go back to your periodic table and look at the location of lead, and this one is called tin. Do you find them in the bottom of group 14? So, although they are in main group elements, but you see they have various charges. So you have to treat them like transition elements. This is called lead 2 ion. And this is called lead 4 ion. The same deal for tin. Tin 2 ion and tin 4. Oops, sorry. I messed it up. Tin 4. I should put parentheses around the charge, not the name. Tin 4. Now, we said transition elements will form various charge cations, except these three elements in the corner of periodic table in the transition element region. Look at the periodic table again. Do you see them in an L-shaped format in the corner of transition elements? So this first one is silver. Silver always will form a positive 1 cation. We don't have silver, 2 silver, 3 silver, 4 silver, any other cation. So instead of being worried about mentioning it like silver 1, you just call it silver ion. That's all. Okay? The second one, you call it cadmium ion, because cadmium can always form only a positive 2 cation. Right? And finally for zinc, zinc always positive 2, so you just call it zinc ion. So if I want to label them, you will say these are various charge. And these are fixed charge. There are the exceptions in monoatomic cations. And we don't have any exceptions in polyatomic anions or in the anions. So very good. All right, so let's practice a little bit on ionic compounds. If we want to write the formula and name ionic compounds, I give you these examples when we start from scratch. On sodium, what is the charge on a sodium ion if it's in group 1? Positive 1, right? I guess I need to change my color. Yeah. Positive 1. On sulfur in group 16 is a monoatomic anion. We subtract group number from 18. After you find out the charges, you need to use only the numbers on the charges, cross them over, and use them as the subscript for the other ion. So you will end up having Na2S1. We never use 1 in our formula, so forget about it. In order to name them, sodium was in group 1, so we don't have to mention its charge. So it's simply sodium. You're dealing with sulfur, just one anion, one element in the anion, so its name ends in IDE. So it's simply sodium sulfide. How about this? Magnesium and chlorine. Magnesium is in group 2, so positive 2. Chlorine, group 17, negative 1. When you cross them over, you will have this formula, MgCl2. And how would you name it? Magnesium is in group 2, so you don't have to mention its charge. Magnesium. And chlorine is monoatomic, so it's called chloride, magnesium chloride. Okay? I showed the charge on cobalt because it's a transition element. I wanted you to definitely use positive 2. On bromine, it's negative 1 because bromine is in group 17, right? So cross them over, crossover rule. For every single ionic compound, basically when you deal with ions, you need to cross them over. So you will have COBr2. Now, cobalt is a transition element. You need to mention its charge. What was the charge? Don't look at these in the final formula. You need to look at the charges. So it's called cobalt 2 bromide. Okay? Alright. How about calcium and SO4? Charge on calcium is positive 2. If you go back to the list of polyatomic anions, it's negative 2 on CaSO4. So after you cross them over, you have Ca2SO4 outside parentheses. Only in ionic compounds you can simplify your formula to change it to CaSO4, and it's just called calcium sulfate. Sorry, I don't have enough space on each page, that's why it's a little bit messy. For aluminum, what's the charge? +3. For NO3 is -1. Switch them over, you will have aluminum and NO3. Whenever you have more than one polyatomic anion or cation, you need to put it outside parentheses. So it is called aluminum just erase the last one, we don't need it. Alright, so we call it aluminum. What was the name of anion? Night. Right, aluminum is in group 13, we don't have to mention its charge. Okay? Let's try to name these compounds. They are already ready for you. So let's try to name them together. If you pay attention, copper is a transition element, right? So you have to mention its charge, but we don't know what the charge is. You will use this fact that although ionic compounds are composed of positive and negative charges, but we don't see any charge on the entire compound, right? So the compound is neutral. So the sum of positive and negative charges, which are cations and anions, must be equal to 0. Now, how to solve this problem of assigning the charge? We see one copper, let me change the color. We see one copper, and we don't know its charge. I normally use the symbol of the element, plus, how many SO4 do you have? You don't have any parentheses and any numbers outside, so it's basically 1. If you go back to the list of polyatomic anions, what's the charge on SO4? -2. The sum of positive and negative charges must be equal to 0. So now, just simply solve this quadratic equation. Okay? Copper -2. So the charge on copper is +2. Now you can name it. It's copper, 2 in parentheses. And what is the name of anion? Sulfate. That's it. So build your simple quadratic equation and find the charge on the cation. Ready for PB? Do you remember PB is an exception? Alright, so the same reasoning. 3PB, we don't know its charge. How many, I'm sorry, it should be PO4. PO4, how many? 2. And what is the charge on PO4 based on your list? -3/2 equal to 0. So 3PB minus 6 is 0, and when you solve it, the charge on PB here is going to be +2. Now you ready to name it together? What was the name of PB? Lead. What is the charge? +2. What is the name of your anion? Phosphate. Okay? Do you need more practice? Li2S, lithium is a main group element. We don't have to mention its charge, so it's just lithium. And the name of your anion is monoatomic. It should end in IDE. Lithium sulfide. A common mistake in students is that they pay attention to this 2 and they call it lithium 2. This 2 has been the charge on sulfur that was crossed over. So You just pay attention to the charges, not the subscripts. For zinc, do you remember zinc was one of those exceptions? So we don't mention its charge, we just call it zinc. And the anion is oxide, so it's zinc oxide. This compound is used in skincare products. Ag2SO3. Remember, Ag is another exception, so it's just called silver, and the anion is sulfite. Be careful, this is SO3, so this is sulfite. And finally, beryllium is in group 2, so we just call it beryllium. We don't need to mention its charge, and the name of our anion is carbonate. Okay, that's naming ionic compounds. I will move towards the other video to start naming the molecular compounds and hydrates, and after them we have the acids, okay?